The first hyperparameter that we will examine for CART is max depth. CART stops splitting when the depth of the tree reaches some specified maximum depth. Smaller values typically mean that the tree is smaller, which makes it less likely to overfit. But if too small, this tree will have a very weak performance, even on the training set. When a model performs poorly on average, then we say that it has high bias. And bias is also a good term to know in machine learning too. In contrast, larger values of maximum depth allow the tree to grow larger, and it will perform better than a tree that's too small. But if too large, it is too complex, and it ends up overfitting. An overfit model is very sensitive to different data sets, so then we say that it has a high variance. And this is another good term to know in machine learning. So hyperparameter tuning, at the end of the day, is about achieving a good bias-variance trade-off. And there are other hyperparameters, such as min-split or min-bucket in R parts, but they're all similar in that they all control the size of the tree. So let me clarify more visually. On the left, we have a tree which is overfitting. The lines are the boundaries that are used for classification. So they are separating class 0 data points from class 1 data points, which have different colors on the plots, as you can see. We can tell that the model on the left is overfitting because it creates a very complex boundary only to classify one point correctly. And I've indicated them in the red circles. So sometimes you have a data point of a different class in the midst of other data points, all of the same class. But here, we're creating very weirdly shaped boundary that are attempting to catch all of these noises perfectly. On the other hand, a more regularized model, such as the one on the right, has a less complex boundary, which will perform better on previously unseen data sets.